Hey guys, we are going to continue to work on application problems for exponential growth and decay, but this time the problems will have percentages. Okay, so first let's start by labeling each variable in the equation. We have y equals a parentheses 1 plus or minus r close parentheses to the power of t. So the a is still the initial value. Like before. The r value, this is the growth or decay rate. Okay, so the growth or decay rate will be your percentage, but you will have to change it into a decimal. And the t stands for the number of times. Okay, so let's do this first problem. It says, Quinn invests $100 in a bank that gains 12% interest each year. Find the value after 5 years. So first I need to label all three of those. I need to know what my A value is, my R value, and my T value. So A is my initial value. How much money is Quinn starting with? He is starting with $100. So my A value is 100. Then I need my R value. I said that my R value is my percentage, which is 12%. But we need to change that into a decimal. So technically, I have my decimal back here after the 12. To change it to decimal from percent to decimal, I have to move that decimal 2 places to the left. Or you can take 12% and divide it by a total of 100%. So just do 12 divided by 100, and you will get 0.12. And lastly, the number of times t. It says that it's gaining 12% interest each year. So it's happening one time a year for 50 years. So that's going to make my t a 50. Okay. So now I'm going to plug these values into the equation. I have y equals a, which is 100, parentheses 1. That 1 will always be part of the equation because I'm getting it right here. All right, it's always going to be a part of the equation. Don't forget that 1. Every year, I have students that forget to bring that 1 down. Okay, then I have to look at my problem because I have to decide, am I going to be adding or subtracting? I can't do both. So I have a key word here that tells me that I'm going to add, and that word is gains. If I am gaining interest, that means I am getting more. There's more of it, and so that means that I have to add. So 1 plus r, I know that r is 0.12 to the power of t, which is 50. So before you plug this into the calculator, let's go ahead and simplify this part inside of the parentheses. So I'm going to get y equals 100, parentheses, I put 1 plus 0.12 in the calculator, and I get 1.12 to the power of 50. Okay. Now I can put all of this into the calculator, and I get that after 50 years, Quinn will have a total of $28,900.22. Okay. So let's go on to the next one. It says, Pedro wants to be cool and buys a Jonas Brothers album on iTunes for $14.99. This album depreciates 6.7% each year. Find the value of his Jonas Brothers album after 3 years. Okay, so again, I'm going to label my 3 variables. I have okay. How much is the value of the album at the start? Well, it cost $14.99. What's my rate that it's going in? 6.7%. But I need that to be a decimal. Now, even though there is a decimal there, it's still a percentage, okay? So we still have to move that decimal 2 places to the left, or you can take 6.7 and divide it by 100. So 2 places to the left, 1, 2. In that second place, we're going to put in a 0. So my percent is 0.067. Okay. And then it says that it's depreciating 6.7% each year. So it's happening once a year. And it's going to happen after 3 years. So that means that the number of times it's happening is depreciating. Okay, so now I come to my equation and I plug in my values. I have y equals I start with my a value, $14.99. I open my parentheses and I have my 1, and then I have to decide if it's plus or minus. So here the keyword that will tell me is depreciate. Depreciates means it's losing its value. So losing means I'm going to subtract. So 1 minus. Then I need my percent, my rate changed into a decimal. So 1 minus 0.067. And my exponent is 3. Okay, so now what I'm going to do is I'm going to simplify again this part that's inside of the parentheses. So I have y equals $14.99, and then the part inside the parentheses comes out to be 0.933 to the 3rd power. Okay. So then once I plug that into the calculator, I get that after 3 years, the Jonas Brothers album will be worth $12.17. Okay. And the last problem. There were 500,000 typewriters purchased in 1970. Because no one buys typewriters anymore, they have decreased 18% yearly. How many typewriters were there in 1995? Again, I need my 3 variables, initial value, my growth or decay rate, and the number of times. So we're starting off with 500,000 typewriters. The rate that it's decreasing in is 18%. But I need to change that into a decimal, so I move my decimal places 2 to the left, and I get 0.18. Again, you can just put 18% divided by 100 in your calculator, and you will see that you get 0.18 as well. And then the number of times. So it says it's decreasing yearly, and we're starting at 1970 and ending at 1995. So because it's decreasing yearly, it's happening once a year. So now we have to just find out how many years. So in order to do this, I'm just going to subtract those two. So 1995 minus 1970 will give me 25. So now we plug this into our equation. I have y equals 500,000, 1, parentheses 1. They are decreasing, so that means I'm going to subtract. My decimal, my rate as a decimal is 0.18. And then my exponent is 25. Again, we need to put the part that's inside of the parentheses inside, in the calculator and simplify it. And when I do that, I get y equals 500,000 parentheses 0.82 to the power of 25. Then we plug that into the calculator. You will get a decimal, however, you're not going to leave it as a decimal because we're talking about typewriters. In the first two problems, we were able to keep it as a decimal because we were talking about money, and money can have decimals. But I cannot have part of a typewriter. So I'm going to end up with, in 1995, there will be 3,502 typewriters. And that is how you solve application problems for exponential growth and decay when there are percentages.